Hello, hello. Good morning, good day, good afternoon, good evening, good night, wherever you are in the world, and welcome to the stream. This is Freaky Physics. Hi, everyone. And we have a small guest here. Show yourself. Hi.
Shy.
That's my kid over there.
Awesome.
Hold on, give me a moment while we're waiting. Yes, what is it?
Awesome. I'm just here to get the tape.
Okay. All right. So, well, no one's here yet, so we're good. But yeah, for today we have an open stream. We do not have a lesson. Our normal lesson for Thursdays is CJ, but he is not in the mood. Well, I said it wrong. That's not right. Okay. He just came from something really grueling, according to the message he sent me, and he's not feeling 100% there. It's not feeling 100%, so he opted to rest today, which is, I think, is always a good idea. Personally, I find that resting is actually more productive than powering through if you don't have any energy to actually do something. What do I mean by that? You've tried it, when you're not well rested and you try to study, nothing gets into your head. Same thing when you're working. When you're working, you need to have ideas, or if not ideas, you need to at least do your work and focus on something. But those things, coming up with ideas, studying, focusing, those are really difficult without rest. So in certain cases, in fact, in many cases, especially if it's physical stress that's getting you, yeah, rest is one of the best things you can do. Okay, no one's in the stream yet, but I do hope I get some people in. All right. Hey, what are we doing today since this is an open stream? Okay, just a few things first. There were no recent updates until today. Yep, so shout out to my editor, Rick. Thank you for doing all the edits, and you're basically, for the shorts, my editor, Rick, his name's Rick, he does like 75% of the work for making the shorts. I do the 25%, but what do I do with the 25%? I just put subtitles in, and I'm the one who uploads. But the one making the cuts, it's him. The one making all the video edits, that's him. And all of these come from these live sessions. Okay, if it's not for the shorts that are not from the live sessions, yeah, I'm the one who makes them. But yeah, so again, shout out to Rick, thank you. But there's a reason behind. He's also the reason why why we didn't update too much recently. He got sick, and like I said, I just told you I prefer people resting over powering through, so I told him the same thing. Okay, so it's the same whether it's for students like you guys, the target audience, or me, or any adult, even kids. Yeah, kids, especially kids. You notice kids when they're exhausted, physically exhausted, and they can't sleep, they're really cranky. But once you get them to sleep, take a nap, and then when you get when they wake up back from the nap, not only are they energized, they're much better behaved. Okay, so that is the power of rest and sleep. So same thing with you guys. If you're listening into this later on, yeah, I really suggest rest. Even me, right now I'm in a bit of a busy spell. Like I got like 2-3 weeks off heavy work. How would I say it? Heavy actual work, not the stream. I wouldn't. I'll get back to that. But yeah, heavy actual work. As a some of you may know this, I'm a full-time teacher already, right? So this is gonna be really one of those things that makes it a lot easier to deal with if you are rested. So yeah, even even me, I need to rest. So in order for me to rest better, I'm kind of cutting back a bit on the videos as well. But again, I do thank Rick for making this stream thing a lot easier for me. So Rick, wherever you are right now, if you're listening, thank you. If not, yeah, shout out to you. When you edit this video later for shorts, you'll hear this definitely. So thank you. Later on, if you want me to shout out something for you, just let me know. All right. So with that, okay. Let me see my tablet. I forgot to charge my tablet today. So yeah, it's ready, but because its battery is low, I am unable to connect it to my computer. So it's gonna take a while before I could actually use the tablet. I'm gonna try that now because I'm now at 2%. Yeah, that's how low it got. Yeah, you heard that. Let me turn off the desktop audio for now. Let's see if this can connect now. I'll turn this off real quick. I'll turn this back on. Okay, so while I'm trying to connect the tablet here, okay, something interesting. Concept-wise, something interesting happened today in class. Okay, and I want to discuss that. I want to just add this in case my students are listening in. But I did mention that I wanted them to try an experiment at home first before I posted anything about it. Okay, but okay, let me just give you a preview for those who are listening in. We did we were talking about the water cycle. Yeah, water cycle. So something a bit basic, but you know, this being part of ecology, so we're gonna look later on into the effects of human activities onto the water cycle. But physics wise, I did ask them to do a certain experiment, which I will. Still cannot be detected. That's really weird. All right, anyway, so my laptop cannot detect my tablet, so I'll give it a few more minutes to charge. Anyway, what I was saying was I gave them a bit of homework, the students. Okay, and since we are unable to do anything here with my board, I'm gonna try to just fix my board here first before I share this with you. I'll use a different option. Hopefully this option works. Kind of works. Okay, that kind of works, so we'll do that. Okay, but okay, I'll just show you the board now. It looks a bit different because I'm not projecting it from my tablet. I'm projecting it onto not from my tablet, I'm projecting it from my desktop. So having said that, that means I'm not gonna be able to use the pen. I'm gonna use my mouse. So hopefully, yeah, I think you'll be hearing all these clicks. Like if you can hear those clicks, yeah. All right, so anyway, the idea is, well, I'm gonna share the experiment I asked the students to do. Okay, and then we'll do the physics out of it on a short later on. I'm gonna do the experiment as well, and hopefully I can show what I was trying to show, what I was asking them to do, and therefore they could discover by themselves. Okay, but anyway, the idea is the idea was about a water cycle, right? Now, there are several processes that are needed for the water cycle. Several processes. One of them is related to this idea. So it starts off with having several, just two. You can do this with a better container, but for now I'm gonna use this. Okay, so you can have a bottle like this, and you can have another identical bottle like so. Okay, then both of this other bottle is a bit bigger, so let's make them same size. There we go. So let's just say that the first bottle and the second bottle both are full of water. What's gonna be the difference between these two? One of the bottles, let's label the first bottle as A and the second bottle as B. The first bottle will be at room temperature. Okay, the second one will be cold. Could be iced, not iced, but could be not frozen, not iced, but it could be, you could have put it in the fridge for a couple of hours before the experiment, but the idea is this must be cold water. Okay, now the second, that's the first one, and the second thing we need is a weighing scale that can measure up to grams. So a kitchen scale would work here. Okay, so something like this. I'm just gonna label this as kitchen scale. Now, if you want to do this experiment, if you have this at home, then what I'll ask you to do is basically do this. So that's the reading and that's your scale. The steps are simple. One, put A on the scale. Okay. Then take the mass reading. Then wait 3 minutes. Then take another mass reading. Okay. Once done, remove A from the scale. Now, this is the first step. The second step of this, of course, when you're gonna take the mass reading, that means you're gonna have to record it somehow, right? The second step is very similar. The only difference is you're gonna put B on the scale. And there. The exact same process, and you do this. Okay, now I did leave them a question, and I'm gonna leave you the same question here. Question here is, does the bottle allow water to pass through? I told my students to use a glass or a tumbler. It works equally well. The main idea is your containers must be identical, and they both must contain water. Same amount of water. Okay. The only difference between the two would be one is at room temperature, the other one is cold. Right. Again, I'm gonna make a short out of this after the students have done this particular activity at home, and then hopefully we can we can go through what I want to point out. Okay. Right. So let's see now. Is there anyone on the stream? Still no one on the stream, but it's okay. I'm just gonna keep talking because I can do that for like an hour if I need to. So that's the first thing I was thinking about. Okay, another thing that came up, and this is a bit of math. I'm not gonna name the person, but if you do happen to come across the stream, thank you for giving me the idea, and thank you for realizing what we were trying to tell you. But yeah, I think this is a really interesting idea. I'm not gonna go through the whole argument, simply because if we go to the whole argument, this is gonna take a while to resolve if we went the way we went. Okay, so I'm just gonna simplify this. So we know that, let's just this is gonna be fractional maths, okay? Fractional arithmetic. Okay, now I'm gonna start off by doing this. What is 1 divided by 2? Again, this is a pretty easy idea to start with, and we know if we write that as a fraction, that's 1/2, or if we write that as a decimal, it's gonna be 0.5. We're gonna focus on the fraction bit. Okay, so the idea here is how first of all, before we go to the actual question, let's go to the essence of that question. The essence that we had on that debate was this: what does the division statement mean? In real situations, okay? So this was the key statement or the key question behind what we were debating. And again, we were able to resolve this no problem at the end. So what does this, again, we're going to ignore the 0.5, so I'm just going to remove that. And what does this mean? For those of you who are more mathematically keen, I think you know what the answer is, but might as well discuss this with you, right? So when you say 1 divided by 2 is 1/2, you can think of this as being what is one possible way you can think about this. What is 1 pi split evenly between 2 people, right? Okay, and the answer is 1/2, and we know that this means each person gets how much pi? Each person gets half of the pie. Gets half of the pie, right? So if we put this into a diagram, so there's your pie, and you have your 2 people, and you want to split it equally between the 2 people. Okay, this means we must cut the pie in 2, and this is 1/2, this is 1/2, and each of them get that. Okay, so I think this part's pretty clear, right? This is where the debate starts. What is 1 divided by 1/2? Now, for mathematics, again, we know that the answer here will be 2, right? The answer is 2. But the question still remains, what does this mean? How come that 1 divided by 1/2 is 2? I mean, I know we've proven it several times before using the equations, and I want to avoid that. Okay, because using the equations, we were able to show it over and over again during the debate that using the equations, it's consistent. But the problem was, yeah, it's consistent mathematically, but the question always goes back to, what does this division statement mean in real situations? Okay, sorry, yeah, it is 2. Okay, now I'm gonna attack this using 2 ways. Okay, there are 2 ways to go through this, and this is the first way I tried to explain this. Again, this was a silly debate, but you know, silly debates are always the more intense ones for some reason. You never get serious debates with as much intensity as these silly debates, right? Okay, so one way we can do this to prove that 1 divided by 1/2 is 2 is if we imagine this. This is a brick, and then we're gonna we're not gonna cut that in half like this. We're gonna cut it in half like this. So we know that this is 1/2. This is 1/2, right? And we know that those 2 will be equal to 1 piece, right? So one way we can think of division, why this gives us 2, is that division, better type this one in, okay, is that division is repeated subtraction. Yeah, division is repeated subtraction, just like multiplication is repeated addition. So for example, what do we mean? I'll give an example first with whole numbers. So in whole numbers, what is, let's make this, what is 15 divided by 3? We know that's gonna be 5, but that is gonna become 15 minus 3, and I'm gonna circle the minus the 3 here, and that's gonna give us 12, then minus 3 again, and that's gonna give us 9, then minus 3 again, then that's gonna give us 6, minus 3 again. Let's just do it like that. That's gonna be equal to 3, then minus 3 again. So this 3 is gonna give us 0, right? So what happens here is how many times did we subtract 3? So this is gonna become 1, 2, 3, 4, 5, and then we ended up at 0. Okay. So let me just add this here. Division is repeated subtraction until until the subtraction cannot be done anymore. Okay. This means that in terms of the remainder, this particular definition is still consistent, but for remainders we'll skip that for now. Okay, so for now we cannot subtract 3 anymore from 0 because we're gonna get into the negative numbers. So for now we'll keep it there. So 15 divided by 3 is equal to 5. Okay, so similarly 1 minus 1/2, and I'm gonna circle that, that's gonna give us 1/2, then minus 1/2 again, that's going to give us 0, and then we have 2 of these. So this means 1 divided by 1/2 is 2. So that's the first way of looking at this problem. So this is one of the more physical interpretations of this particular statement for 1 divided by 1/2 is 2. Okay, but another one, and I'm gonna go to this next bit. Okay, another way you can look at it is this. I'll just put that here again. 1 divided by 1/2 equals 2, right? So the other way we can look at it in this particular case is we're gonna say what is let's say we have a group. Okay, so if you have one group, and this is where the debate kind of stopped, because the person we were debating kind of went through this route and convinced, and we all got convinced that this is a good explanation. Honestly, I personally think this is a really good one. Okay, so let's say that this group, let's say, has let's put it in as 100 people. Okay, but what the more important thing here, no, actually no, let's not put that as 100 people. Let's put this group as, let's make it 20 for now. 20 people. Okay, there we go. So in these 20 people, and let's say that I'm gonna have to hold on, let me see how the argument goes again. So if that's just one group and there's 20 people, and then I'm gonna have to give something to this group. So let's say I'm giving this something to the group. Okay, let's say this is food to the group, but the food is not enough. Okay, so there, the food is not enough. In fact, I'm gonna write it in a different way. It's enough only for half the group. There we go, which is 10 people. We know that this means this is 10 people. Okay, so in order for this to go, you can think of it this way. Each person, so let's say this food, these are 10 servings, right? So you can think of this as having 20 people, and I'm gonna, okay, and this is where we kind of did it right. Okay, but anyway, the 1 2 3 4 5, 1 2 3 4 5. Okay, so these are, so if we break this group into the smaller groups of 10, so again, half of that, then 1 2 3, one more 5, and then 1 2 3 4 5. Okay, so 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 10. All right, so if you're gonna divide these the whole group into two groups, and you're gonna have to put this serving in here, each person will get a serving here. 4 5 6 7 8 9 10, right? But what if they shared? Because there's only 10 servings, they shared, so that this only gets half. This only gets half. This only gets half. Half. And so on, right? Half, 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 and half. Because they're sharing, they're giving their half to these people here. So half of here, 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 and so on. Okay, I'll just finish that. The idea here is, since each person now has half a serving, okay, you can interpret this way. So 1 divided by 1/2 means you have one big group and then you're giving them half a serving each, right? Half serving means you can feed two. This 2 would mean 2 smaller groups can be fed. Okay, so that's one possibility of interpreting this. Okay, so again, 2 smaller groups are made wherein each group can have half a serving from the one big group earlier. So this is one possible interpretation of that. All right, so yeah, that was another interesting we did last week, over the past weekend. Just so we know, so okay, whoever we were talking to here, those who were involved in that debate, if you were watching this later on, you know who you are. Yeah. I hope I did the explanation right, but the one that got it right. Okay, but that's one way of doing it. Right, so let's see. No one is still on the stream. I've been talking to myself. Well, hold on. Maybe I'm mistaken. Let me check. Okay, here. No one's viewing on. It's fine. Doesn't really matter for me. There we go. Okay, and there we go. Okay, so anyway, so that's it for that particular bit. Since no one's still here in the stream, let me try to come up with an idea here. Ooh, okay. Right, so let me just get back to the board. Okay, there we go. What's another idea that we had? Okay, so while we're okay, before I go back there, let me see if I can use the tablet now. Hold on. Okay, give me a moment. Let me try it on. Okay, I think I'll just exit and try it again. Ah, there we go. I can use the tablet now. Hold on. Let me just get back to the main board first. So while I'm doing this, yes, the tablet's working now. So that means, where is my Jamboard? And I'm gonna put that over here. And let's fix that. Ah, there we go. It's fixed. All right, so we're now on the board and I can use my pen. There we go. All right, so what's another thing I can talk about here? Okay. I think I want to show you something. Good thing I got this new camera. Well, this is not really a new camera. This is an old camera which I hacked. And okay, I'm just gonna show you what I have right here. Oops, I better turn off the filters first. Okay, let me turn off the camera filter first so you can see that clearly. Chroma key filter off, and all right, so for now there. So hopefully you can see that. In case you can't, let me put that on there with a flashlight so you can see more clearly. Okay, so here I have some pots, you can see hopefully, and the pots have Venus flytraps in them. Yeah, currently I have 1, 2, 3, 4, 5 Venus flytraps, but as you can see, they're in a box. I think I mentioned this before. Okay, so yeah, I did mention this before that I have Venus flytraps, and what I'm doing right now is I am putting them under dormancy. Okay, so again, what's dormancy? Venus flytraps are actually perennial plants. In other words, okay, hold on, let me just put the camera back on. So Venus flytraps are perennials, meaning they actually live year after year after year with the correct care. All right, so there's my green screen. You can see that. Let me put it back on. Hold on, let me fix that. Okay, put it back on. There we go. All right, so Venus flytraps, if we go back to the board, okay, Venus flytraps are perennials. So let's do a bit of science of Venus flytraps. Okay, so there we go. Here's the eraser first. Let's fix that. So the science of Venus flytraps and why I have that box. Okay, so Venus flytraps What's wrong with my board? Hold on, let me refresh the board. That looked really weird. Okay, so Venus flytraps. There we go. Okay, now Venus flytraps, we know these as carnivorous plants, and thing is, Venus flytraps come from most of you should know that Venus flytraps are native to the United States. They're not native to the tropics. Okay, Venus flytraps are not only native to the United States, they're native to a particular part of the United States only in the wild. You can only find them in, if I'm not mistaken, somewhere in North Carolina. Now, North Carolina, I've never been to the state, so I don't really know this for sure. But North Carolina, from what I understand, has a relatively mild winter season. Mild. Okay. So what does that have to do with this? This means that Venus flytraps are actually exposed, wild ones at least, they're exposed to winter conditions. Or in other words, let's just not use the word winter conditions here. These are cold weather conditions at least once a year, right? Once a year. Okay. So if they're exposed to these types of weather conditions, that means they have the proper adaptations, or they have evolved to have these adaptations to survive in winter, right? So they must. Okay, and also let's write that other thing that I said earlier. These are perennials, right? So perennials are plants that do not die every year, or not every other year. They keep living for year after year after year for at least 3 years before they die. And when they do that, they don't just store food every winter. They actually store food and then use it to grow. They'll store food again, use it to grow. So perennials, in theory, could actually live indefinitely. Okay. So anyway, going back here, these Venus flytraps are perennials, and they're exposed to cold weather conditions at least once a year. What I mean with that is the winter season comes, right? So that means they have adaptations to survive in winter. So if you remove, now the adaptation is this, okay? They enter, I've mentioned this earlier, a state of dormancy. Every winter. Now, Venus flytraps actually are so used to having dormancy periods every winter that, okay, that means for them, excuse me, remove their dormancy period, they die. Okay, so again, Venus flytraps must enter that state of dormancy at least once a year, or else they're gonna die. They're not gonna last as long as they could. Okay, so that's what the box is for. Oh, I did take a screenshot of the box, so I'm just gonna describe, well, not describe, I'm gonna draw basically what the box is. Okay, so the box is essentially 2 layers of something. The first layer, this is styrofoam. Okay, and then I have a second layer on the inside. I put this particular layer on the inside myself. That box is DIY, by the way. So this is a DIY box. Okay, so there we go. Now this particular section, okay, this is polyurethane. Foam. Now, why do I have polyurethane foam and styrofoam here? These are the 2 best materials that you can have to insulate something that is not, well, that is made of plastic. Again, these are the two best plastics for insulating something. So polyurethane is actually better than styrofoam, but it's not, as the one I have isn't rigid. If I had rigid foam, I would have just used polyurethane. Okay, so back to the idea. Very good. Or I'm not just gonna say very good, I'm gonna say excellent. Okay, these have excellent thermal insulation properties. Okay, now in other words, once I have this box, I can actually just put my plants in there and kind of keep it cool, and it should work, right? And then for the cover, and I'm just gonna use a different thing here. For the cover, I used a double layer acrylic sheets. Acrylic is also quite a good insulator, but nowhere as close as polyurethane or styrofoam. But the key idea here is, even though that acrylic is not as good as an insulator, the fact that I'm doing a double wall is gonna help. Okay, what's a double wall? I'm just gonna explain it here. So for example, we have let's take a look at the side. Okay, so this is the first layer of acrylic. Okay, some of you may know acrylic as plexiglass. Okay, now I have here, this goes all over the place. This is some styrofoam again. Okay, styrofoam is actually a trade name. The correct term for the non-styrofoam brands is expanded styrene foam, or expanded polystyrene foam. Okay, so this is also acrylic. Okay, and of course I have some styrofoam here. You can imagine that on this side and on the other side, it's also got styrofoam. But the key idea is this: once this is in, this is just air. Okay, and all of these are held together by a nut and bolt. So nut and bolt, right? So this nut and bolt is going to compress the styrofoam in between the acrylic sheets. Now, why is this the idea? Because this uses the fact that air is a really good it's fact, I'm not even gonna say really good, I'm not even gonna say excellent here. I'm gonna say is one of the best insulators there. Okay, so this clear acrylic sheet being doubled up like this and separated by styrofoam and keeping a layer of air in the middle actually achieves one thing. It still does the insulation, but at the same time, because the acrylic is transparent, this means light can come into the box. Okay, now what's the physics here? There's a lot of physics here, but we'll get to that later. Okay, I just want to talk about the box itself because I find it rather interesting to just come up with these things sometimes. Yeah, I came up with this box by myself. What I did was, this is like a 3-year process, just so we're clear. This was a 3-year process. That's how long it, well, the whole box itself didn't take 3 years. The box itself took me like a few hours to construct. But the idea was, within those 3 years, there's a prototype for boxes. The first prototype was a single styrofoam box. Let's go back here. So the first prototype was, it was just a styrofoam. Okay, so what did that run into? The problems that ran into? Well, because it's just a styrofoam box. You know, one of those really cheap disposable styrofoam boxes? Um, they're usually used as makeshift, not even makeshift. They're used as like emergency coolers. Okay. Yeah, it worked. But then again, I thought, there's no light getting into the fly trap, so they don't really get enough light because here's the thing, they're dormant, they're not hibernating, they're not dead, they're just dormant. That means they still would like some sunlight here and every so often to come in so they can still photosynthesize. They're just dormant in the sense that they're more like reserving their strength and gathering resources for them to grow after dormancy. So let's just compare. Prototype 1 was just a box. So I'm just gonna draw it like this. Okay. But the cover was original. So what were the main drawbacks? No light. That's the first one can come in, right? For the plants. The second drawback that I've noticed is that the difference in the temperature. You see temperature all of a sudden, so we're getting into the physics. The maximum difference in temperature that I could achieve with this box. Okay, I'll explain later what this is. But the maximum temperature difference I could get with the prototype, if I'm not mistaken, is around 10 degrees Celsius. Maximum. Actually, no, not even. 5 degrees. Yeah, around 10 degrees Celsius. Oh, okay, I see people now. Pink sheep is here. Newton's laws. Do we have time to go through Newton's laws? Maybe when I'm done with this particular part, but sure. Okay. Can you tell me what exactly about Newton's laws there? Hey, Pink Sheep, I recognize you. Thank you for saying that. Alright, so anyway, going back to Prototype 2. What was Prototype 2? Prototype 2 was basically the cover. Was still the original cover. Okay. But here, Prototype 2 now had a cooling system. Okay. The cover was still original. I'm just gonna say cooling system. I'm not gonna go into the details of the cooling system yet. Okay. Cover was still original, but with a hole. Not a hole, but with light installed. Okay. So the drawback. Pink Sheep. I understand what that means. Can you please delete that? I know who you are. Okay. I'm not gonna tolerate that language here, please. Thank you. YouTube and Tilbolong, I know what that means as well. Okay. If you keep doing that, I'm gonna ban you from the. Okay, I'm banning you guys. Thank you. Sorry about that. I really look forward to having that, but I am gonna block you from the stream. Bye bye, the two of you. You're from YouTube, so let me do that quick. So where is it? Hold on. There we go. There we go. There we go. And you too. I'm also removing this. Remove. And remove. And remove. Okay, and I'm also removing that from the actual chat. You can see from here. Well, this basically just tells me I need a mod later. But let's refresh this. Okay, so anyway, back to what I was saying. So, fortunately or unfortunately, we got those kinds of viewers, which you would expect from, you know, the age bracket that I am trying to target. But going back here. But the thing is, with the lights installed, what happened was, the difference in the temperature, the delta T here, was only around 8 degrees Celsius. And this is the third prototype. Okay, the third prototype, I got the same box with thicker insulation. Basically, I removed the cooling system, but the cover is the clear glass. Okay, clear, and then what was it? The light comes from outside. Okay, in all of these cases there was ice inside. Okay, so in all of these cases there was ice inside. Delta T here that I achieved was 15 degrees. There we go. Okay, so what's that delta T? Delta T here would be the temperature on the outside and the temperature on the inside, and delta T would be T out minus T in. In other words, it's a difference in the temperatures inside the box compared to outside the box. So prototype 3 has worked well, really well actually. So later on, prototype 4, and I'm just gonna say it here, prototype 4, it's gonna be for 4, we're gonna have the cooling system. This is gonna happen next year. Okay, so hopefully the cooling system is gonna even help it get to a bigger temperature difference from what we have now. All right, let's go back here a bit before we end. Venus flytraps, if you really need to take care of these and put them into a sort of some sort of dormancy, this should be around or approximately 10 degrees Celsius on average. Okay, I see another one on the chat. Hello, yes, King. Can you read that? All right. Now. Okay, so on YouTube, so you're here. Let me just go back real quick. Okay, so anyway, going back here. So basically, okay, so the temperature I need inside the box should be around 10 degrees. Okay, I'm gonna remove this, and I'm gonna remove this as well. Okay. Yeah, so for Venus flytrap, since that's the idea, the bigger that temperature difference is, the better. But of course, we need to keep it within limits. So the idea here is later on prototype 4, I'm gonna try to put the best of the prototype 3 and prototype 2 together, see what kind of temperatures we can get in. And hopefully, from there we can automate the box. All right, so we can do that. Okay. All right. Okay, so any questions? Yes, King. Since you're already there, I'm gonna stay in the stream for another 2 minutes, unless you have questions. You have any questions? And I see also Freaky Scientist. Hello. Okay. Well, you know, it's up to you how you see it. Is it important later in the future? Well, I gotta ask you something. Today was somebody else's future a long time ago, right? That's all I'm gonna say. And okay, so what gave us all the modern advances? It's the different sciences, physics included. Okay, chemistry and biology gave us medicines, how to make food, fertilizers, a lot of things. Physics gave us electronics, electricity, GPS. Okay, so all of these modern conveniences that we now take for granted, yeah, they were once theoretical. They were once under the sciences. So yeah, that if you think physics is important later on in the future, the answer is yes. Okay, so all right, so we'll end here. Okay, so I guess we can end the stream here because you guys came in late. All right, so we'll end it here today. Yep. So let's just do a quick thing before we end. So again, don't forget later on, once you're done, subscribe to these channels. I do the announcements on Facebook, TikTok, and Instagram. I do the live streams on Facebook, YouTube, and Twitch. Of course, at the end, don't forget to go to Freaky Physics at XYZ. Again, not .com, it's XYZ. Okay, so with that, we will end tonight. So for me, it's nighttime. So wherever you are in the world, good afternoon, good evening, good night, good morning, good day. And I'll see you next time. Stay freaky, everyone. Bye-bye.